Hello everyone. In a very special way, I want to welcome you for a continuation of a study that we had commenced on a topic known as chemistry of metals. In our previous lesson, we looked at the extraction of lead metal from its ore. Today, I want us to understand how iron metal can be extracted from its ore. So number one, as usual, we must know the major ore. Number two, we must know the minor ores. Number three, we must know the major impurity. And number four, we need to know how to purify the ore so that we obtain a more purified ore for reduction process or for extraction. The major ore in which iron exists is known as hematite. So we have hematite. Hematite is iron 3 oxide. The minor ores in which iron exists, we have got 3 of them. But remember the meaning of a minor ore. A minor ore is an ore which contains a metal but in small quantities or mega amounts. But a major ore is an ore which contains the same metal but in abundance or in large quantities. So the minor ores of iron, we have got magnetite, which is triiron tetraoxide, Another minor ore, we have pyrite, which is iron sulfide. Then also we have another one known as iron carbonate, or you can call it siderite. Siderite is another minor ore of iron. Now, after having known the major ores and the minor ores of iron, now you must know what follows. If extraction is done using the major ore, which is the hematite, then it is used in that form of oxide. But if the major ore cannot be found or is unavailable, the only ores which are available in this case, for example, iron sulfide or iron carbonate, then they must be converted to a stable oxide of iron, which is the hematitic state. So if, for example, the only available ore of iron is the iron sulfide, it must be roasted. It must be roasted to mean it is reacted with oxygen to form iron 2 oxide and sulfur 4 oxide. And being that iron 2 oxide is unstable, it is reoxidized to form iron 3 oxide, which is now having the formula as the major ore. But if the only ore that is available is iron carbonate, then since it cannot be roasted, it is thermally dissociated or decomposed to form iron 2. So we have got thermal dissociation. For iron sulfide we use roasting, but for the carbonate we do what is called thermal dissociation or thermal decomposition. That is decomposing iron 2 carbonate to form iron 2 oxide and carbon 4 oxide. Now iron 2 being unstable is reoxidized to form iron 3 oxide, which is now stable, that cannot be used for what? For reduction process to obtain iron from its ore. Now, after having done that, what follows is very simple. What follows is very simple. The ore is purified. The ore is purified. But remember, the major impurity in iron, is very simple. Major impurity in iron is very simple. Is silicon. just as lead, the major impurity in iron is simple, silica. Now silica has to be removed. And the removal of silica takes place in the furnace, so we will be looking at it later. Let us do the general purification of the ore, known as a froth flotation method is used. So in this method, a mixture of oil and water is passed into a column containing the impure ore. The impure ore, for example, we can say a hematite, the major ore. Remember, the major ore is not roasted. It is taken the way it is and purified. But if you're using these other ores, you must convert them first into oxide. But for the major ore being in an oxide state, we don't need to convert it further. It remains in that oxide state. Therefore, what we can do is just be doing the purification of the ore by a process known as froth flotation. And I've said we pass a mixture of oil and water, which is known as frothing agent, into a column containing the ore. Now, the frothing agent removes and separates the impurities from the ore, making them to sink because they are more dense, leaving the ore floating. Now, the ore that is floating is skimmed off and removed, collected here and dried. Now, the process by which the impurities are removed as they sink at the bottom, leaving the ore floating, the ore is now called froth. Since it is moistened, that process is known as froth flotation. Now, once that has been done, the froth or the ore which has undergone the purification is passed into a furnace. Now, the furnace has got three parts. But before we look at what happens at the furnace, the ore is not passed into the furnace alone. It is mixed with coke and calcium carbonate, the limestone. And the same role that limestone played when we were dealing with extraction of metal, the same role will be applied here. So a mixture of coke, iron, and calcium carbonate is passed into the furnace through the upper part. Now we have got three parts of the furnace. We have the upper part. We also have the middle part. And we have the lower part. It can be this side, the lower part. Now, the ore, together with coke and limestone, is passed into the furnace through the upper part. Now, the coke, the limestone move until the lower part. Remember, at the lower part, we have hot air blast. 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 Now, when coke and limestone have trickled to the lower part, coke reacts with oxygen from the air to form carbon 4 oxide. Remember, the temperature at the lower side before the introduction of these two things is at 1,000. It's at 1,000. When the coke is introduced into the system, into the furnace, it reacts with carbon 4 oxide. So at the lower part, we have carbon 4 oxide reacting, we have carbon reacting with oxygen to form carbon 4 oxide. The reaction is exothermic because the heat is produced, the temperature increases from 1000 to 1600. The temperature increases from 1000 to 1600 degrees Celsius on the lower part of the furnace. Now, carbon 4 oxide, due to high temperatures, and since it exists in gaseous form, it rises to the middle part. Now, in the middle part, carbon 4 oxide is reduced by the unreacted carbon from carbon 2. Carbon 4 oxide gas is reduced by carbon or coke to form carbon 2 oxide, which will be used as a suitable reducing agent. And this reaction is endothermic, meaning the heat is absorbed, denoted by a positive sign. So the temperature that was maintained at the middle part initially was 800, but because of endothermic nature of the reaction taking place at the middle part, it simply means the temperature will decrease from 800 to 600. Now, carbon 2 oxide gas produced goes to the upper part. Now, in the upper part, reduction occurs. That is, iron 3 oxide is reduced by carbon to form iron metal and carbon 4 oxide to form iron metal and carbon 4 oxide. Form iron metal and carbon 4 oxide. We can balance it by having 2 here, for example. Let's see how it is balanced. Let's say we have 2 here, then we have 3, then we have 3. So we form iron metal. Now iron metal trickle to the bottom. Iron metal trickle to the bottom. Now, before we explain what happens when iron has trickled to the bottom, this iron metal is impure still because the impurity has not been removed. The silic has not been removed. Now, calcium carbonate, which was added together with coke, is decomposed due to high temperatures to form calcium oxide and carbon 4 oxide gas. Carbon 4 oxide gas is recycled back to the middle part where it is reduced to form carbon 2. Now this calcium oxide is used to remove the impurity known as silica in form of calcium silicate. And that one occurs at the lower part, and by the way, that impurity settles on top of iron which are trickled at the bottom, since it is less dense than iron. Now the iron settle at the bottom as the slag, calcium silicate formed, settle on top of iron since it is of low density compared to iron. And the iron comes out in form of pig iron. We call it pig iron because it is not 100% pure. It has got some traces of impurities like phosphorus, manganese, sulfur. Now those ones were not removed. We have all removed the silica and other impurities, but manganese, sulfur, phosphorus were not removed, and therefore they make iron not to be 100% pure. And for that reason, it is known as what? Pig iron. Now, this slag, which is known as calcium silicate, is removed from the furnace. Since it is able to flow, it exists in molten state. Now, we have obtained the pig iron. It is impure. How can it be purified? Through a process known as electrolysis. So, the purification is done by a process known as what? Electrolysis. Whereby, as I had explained during the extraction process of lead, the same thing applies. Only that in this case we are doing the purification of iron, but the same process is followed. Now, anode is the pig iron which was obtained from the extraction process. It's an having manganese. And the cathode is the pure iron. And then automatically we must have the DC direct current. And then you dip it into its own solution, same, or you can say iron sulfate or iron nitrate. Yeah, 2 nitrate. Now, the pig iron dissolves into its own solution, producing ions. We have got iron dissolving into its own solution, producing ions and 2 electrons, which flow in that direction. Now, ions which are produced as iron dissolves migrate to the cathode. Where they are deposited or reduced to form pure iron metal, leaving behind the impurities known as sludge. They can be sulfur, phosphorus, manganese, and so on. So that is the simplest way in which a student should be able to understand the extraction of iron metal from its ore. Uses of iron can be used to manufacture iron sheets, since ions can be hammered into sheets. Iron can also be used as a catalyst. Iron can also be used as catalyst in various industrial processes. It can be used as an iron metal, or it can be used as an alloy. An alloy of cobalt and iron can be used as a catalyst. May God bless you. Any question you are allowed to ask. Thank you so much.